Welcome to Algebra 2, Chapter 3, Section 6 from the Big Ideas Math. The essential question is, how can you solve a quadratic inequality? Now, the neat thing about this lesson is you are going to use everything that you have learned about graphing quadratics, and then we're going to take it one more step, and we are going to do some shading. So go ahead and grab your cheat sheet, and you're going to see graphing a quadratic inequality in two variables. The first step is to graph the parabola, pretending that it's an equal sign. See how they pretend it's an equal sign here? And then you need to use a dashed line or a solid line depending on the inequality symbol. So when do you use a dashed line? If the symbol is less than or equal to. And you use a solid line if the symbol has the or equal to underneath it. Now, the way I remember this is the less than or equal to and the greater than or equal to have a line underneath it. It's a solid line, so I'm going to draw my graph with a solid line. All right, step 2 is our important part here. That is where we do our test point. And we want to graph where it's true. And so I like to just say to myself, shade the true. So the true region is going to be the shaded region because that is where all of the solution points are for our inequality. So step 3, they kind of spell it out for us. They say shade the region inside the parabola if the point from step 2 is a solution. Shade the region outside the parabola if it is not a solution. In step 2, notice they tell you your test point xy needs to be inside the parabola. Truth is, we can test wherever we want to as long as we shade the true region. So let's go ahead and get started here. It says graph y is less than negative x squared minus 2x minus 1. All right, first steps first. If we're going to graph, what do we need to know? We need to know the line type. So that is going to be dashed. What else do we need to know to graph? We need to know the vertex. So remember, the vertex is the opposite of BA, the opposite of B over 2A, comma, something. So I've got the opposite of B over 2A. 2 over 2 is negative 1. Now I'm going to take that negative 1 and I'm going to plug it in. Negative 1 squared is 1, but there's a minus out here, so I have negative 1 plus 2 minus 1. And negative 1 plus 2 is 1 minus 1 is 0. So my vertex is negative 1, 0. It's right here. Okay, now remember how we pick our points. Here's our x, negative 1, 0, and our f of x. And you want to pick the 2 points on either side of that point because you know they are going to have the same y value since our parabolas are symmetrical. So I'm going to have 0 and negative 2. And then you pick the next 2 points on either side of that vertex. So that would be 1 and negative 3. And now what do? We plug it in. So pause the video if you don't want the answers here. I got negative 1 and negative 4. And I lost my pen. And yet I am recording. See if I can get it back. There it is. Okay, so 0 is negative 1. and -4. Now, we'd already determined that the line type was dashed, so you want to be careful at this point. Make sure it looks like it's dashed. Don't do a solid line and erase it. It might still accidentally look like it's solid. So that's pretty good. And now we get to determine our shading. So, shading is when you pick a test point. Remember step 2, they said to pick inside. But we are smart, and we know that the easiest point to pick is 0, 0. Remember, you can pick any point as long as it is not on the line. So I'm going to plug a 0 in for the y value and a 0 in for the x value. So I get 0 is less than negative 0 squared minus 2 times 0 minus 1. So 0 is less than -1. Is that true or is that false? 0 is less than -1. I hope you got false. So since our point is false, it's wrong, that means I need to shade the true, and the true is not where our point is. Our point is on the outside, which means I need to shade the inside of this parabola. So that means all of the points on the inside of the parabola are solutions. Because the line is dashed, any point on the line is not a solution. All right, let's try the next one. Oh good, a story problem. It says a manila rope used for rappelling down a cliff can safely support a weight W in pounds, provided that W is less than or equal to 1,480 times d squared, where d is the diameter in inches of the rope. Graph the inequality and interpret the solution. All right, well they've already given us a graph, but they haven't shaded it yet, so let's go ahead and check out their graph here. It's a solid line because it's less than or equal to, and we need to determine the shaded point. So in order to do that, we can plug in anything we want, but we can't tell that 0, 0 is on the line or not on the line. And they gave us 1, 3000, so we can just use that point as a safe choice. So let's go ahead and plug that in. We have 3000 is less than or equal to 1480 times 1 squared. All right, well, 1 squared is 1, so we have 3000 is less than or equal to 1480. Is that true or is that false? I hope you said false. And since the point is inside of the parabola and it's false, I know the shading needs to be on the outside of the parabola. Now, interpret that solution. What's that mean? Well, that's the area, or the solution set, that is true, that is allowable for the rope. So let's go ahead and think about this. If we have a rope that is 2 inches in diameter, any of these weights, all the way up to the function, are allowed. So we can't see our function, so let's try this one instead. Let's say our rope is 1 inch. Any of these weights are allowed. Now, as soon as you get to, what is that? 1,500. As soon as you get to 1,500 pounds, it's 1,500 pounds, that 1 inch diameter rope can no longer support you, or the weight you're trying to put down the cliff. That is what our solution set means. Okay, remember guys, stop your lesson at any point and ask me if you're having problems or questions. We're going to move on. It says graph the system of quadratic inequalities. So what we're going to have here is 2 parabolas on the same graph paper, and their shaded regions are going to overlap. So I'm going to go ahead and just color code this. Grab your colored pencils and color code yours too. It helps to know where the solution set is. Okay, I'm going to get my blue back here. Well, if the opposite of b over 2a is my vertex. And for my blue function, I can see that there's no x value. That means it's 0 over 2a, which is just 0. Okay, so I'm going to plug 0 in and get 3. And I'm going to go ahead and make my t-chart here. With 0, 3. And I'm going to choose the two numbers I know are on either side of 0. And the two numbers on either side of that. Okay, 0, 3 is up here. And I'm going to go ahead and plug that into my calculator. So pause the video if you don't want the answers right away. And I know you don't. I know you're going to do the work yourselves here. All right, so I got 2. Whoops, sorry about that. 2 and -1. And I have lost my pen again. Just like the last time I paused the show. Ooh, now we're working. Okay, I got 2 and -1. So just catch up, meaning I need to catch up. Here we go. 1, 3. And then, was this supposed to be opening down? Yes, yes it was. And what's the line type supposed to be for this blue graph? Hopefully you see it's supposed to be dashed. And then, are we allowed to test 0, 0 as our test point? Yes, thankfully we are, so plug that in. 0 is less than -0 squared plus 3. So 0 is less than 3 is true. So since 0, 0 is right here and we get to shade the true, this time we are shading the inside of the graph. Use your colored pencils. Do not go for blackout shading. Just lightly shade it in with your colored pencil. I've got blackout because I'm on a computer here. Alright, let's switch and do our green function. We're going to do the opposite of b over 2a. So that's -2 over 2, which is -1. So I need to plug it in. And I need to make my table. Here's my x's, my y's. -1. On either side of -1, I have a 0 with a -2. And a 1 with a -3. Okay, I almost hate to press pause here, so I'm not going to do it. You go ahead and press pause if you want. I'm going to type this into my calculator real quickly. And I get -4 to go along with my -1. -3 to go with my 0 and my -2. And 0. So let's see here. -1, -4. It's right here. And now I'm opening up. And my line type is supposed to be solid. I came in a little bit too wide, but that's okay. Nobody's perfect, right? We'll pretend that's okay. And then we get to test 0, 0, so let's plug that in. 0 is greater than or equal to... Now I'm just writing this down for fun. You guys know that's going to be 0, right? So 0 is greater than or equal to -3, which is true. So since 0, 0 is here, that's where we get to shade. Now I'm going to grab the yellow and show you. That means the solution set is this solid line, this dashed line, that's dashed, I'm trying to make it dashed, it's not working, and all this shading in between. Okay, let's try another one. Alright, so it says graph the inequality. We've got y is greater than or equal to x squared plus 2x minus 8. And we need the x value of the vertex so we can make a table. So go ahead and start with that. Whoops, I'm still in yellow here. I've got negative 2 over 2 times 1. Okay, so negative 2 over 2 is negative 1. So I'm going to have negative 1. On either side of a negative 1 is a 0 and a negative 2. And then one more unit out from that is a 1 and a negative 3. Grab your calculator and plug it in. X squared plus 2x minus 8. Plug it in, plug it in, plug it in. You should see that negative 1 is negative 9. The 0 and the negative 2 are negative 8. And the 1 and the negative 3 are negative 5. Okay, so 1's negative 9. Let's get it here. Your 0 with your 8. Okay, now what kind of line do we need? A solid line or a dashed line? Because it's greater than or equal to, we're going to have a solid line. And this is great. I can clearly see that 0, 0 is not on the line. So I'm going to plug that in. I'm going to get 0 is greater than or equal to negative 8. Now I skipped that step of plugging it in and squaring it and multiplying it to the 2 because anything times 0 is just 0. Is 0 greater than or equal to negative 8? Yes, that's a true statement. So since 0, 0 is right here and it's true, we are going to shade the inside. And we are done. Moving on. Number 2, graph the inequality again. It's 2x squared minus x minus 1. And it starts with y is less than or equal to. Alright, so I'm already thinking that my line type is solid. I've got the opposite of b over 2a here. And I'm so thankful I'm using my calculator because that's 1/4. Alright, so I'm going to pick some values on either side of the 1/4. Well, we know 0 is always a good one to pick. Here's my 1/4. The problem is picking the symmetrical units. That's supposed to be an x there. Alright, so go ahead and grab your calculator. We can use our calculator to help us find our whole number, or our integer rather, points that will be easy for us to plot. Okay, so I'm getting that 0 is supposed to be negative 1. I'm getting that 1 is a 0. I'm getting that negative 1 is a 2. Negative 2 is a 9. And I haven't figured out the value for 1/4 yet because I need to go back there. And for 1/4, I'm getting negative 1.125. Alright, never fear. Still a yucky one, but we can handle it. So 0 is negative 1. 1 is 0. Negative 1 is a 2. Negative 2 is a 9. I really need 2, don't I? I'm going to go back to my calculator again, figure out 2 is a 5. So see, now this one we are not using the symmetrical property for inequalities. We're just plugging and chugging by hand to get it. Alright, good enough. We said it was solid. And can we use 0, 0? Yes, yes, we can. Plug it in. Y is less than or equal to negative 1. So 0 is less than or equal to negative 1. We know is false. Since 0, 0 is on the inside, we shade on the outside. So all of these points on the outside of our parabola are our solution set. Okay, let's skip this one. Let's do the system. It says y is less than or equal to negative x squared, and y is greater than x squared minus 3. All right. Well, we can see right away that vertex is 0, 0 for negative x squared. Let me go ahead and color code these. This will be my blue function. Ooh, I'll erase and start over. Now I've got 0, 0 there. And then over here, I know I have 0, negative 3. Okay, back to our blue function. Y is less than or equal to negative x squared. We just do this quick by hand in our head. 1 and negative 1 are going to be the same. 2 and negative 2 are going to be the same. If I plug a 1 in there, I'm going to get negative 1. And if I plug a 2 in there, I'm going to get negative 4. So this little guy goes like this. What kind of line is it? Hopefully you said solid. Done. The graphing was easy, but guess what? We cannot choose 0, 0 as our test point because this graph goes through 0, 0. So we need to choose another point, and it would be nice if it were an easy point. Let's say maybe 0, 2. 0, 2 is right here. So 0, 2 is our point, which means I say 2 is less than or equal to negative 0 squared. 2 is less than or equal to 0. Is that true? No, it is false. So since it's right here, and it's on the outside, I have to shade on the inside. Okay, switching to our green function, y is greater than or equal to x squared minus 3. I saw immediately that the vertex was 0, negative 3. And that means 1 and negative 1 are the points on either side. And 2 and negative 2. And now I need to plug them in. You should get negative 2. And you should get 1. Negative 2 and 1. And check the line type here. The line type on this one is dashed. And can we use 0, 0 as our test point? Yes, yay, we can. So go ahead and plug it in. 0 is greater than or equal to 0 minus 3. 0 is greater than -3 is true. So we were at 0, 0, which means we shade the inside. All right, so where is the solution? Let's really take a look at this. The solution is the solid line here, the dashed line here. That's supposed to be dashed, but it's not looking dashed, is it? And this shaded region on the inside. All right, your practice work is next. Let me know if you have any questions.